What's happening inside the Earth? In this video, we will explore the different layers of the Earth and the various processes that occur within them. From the molten core to the outermost crust, the Earth is a dynamic and ever-changing system, and we will explore some of the key processes that drive these changes. Layers of the Earth. The Earth is composed of four main layers: the inner core, outer core, mantle, and crust. The inner core is the most central part of the Earth, and it is a solid ball of metal that is mostly made up of iron and nickel. The outer core, which surrounds the inner core, is a liquid layer also composed of iron and nickel. The mantle lies above the outer core and is the thickest layer of the Earth. It is made up of hot, semi-solid rock and is responsible for driving many of the geological processes that we observe. Finally, the crust is the outermost layer of the Earth and is the thinnest layer. It is made up of tectonic plates that are constantly moving and interacting with one another. The core. Let's begin our exploration of what's happening inside the Earth with the core. The core of the Earth is a critical component of our planet, as it generates the Earth's magnetic field. The Earth's magnetic field is what protects us from harmful solar radiation and allows us to navigate using a compass. The core is composed of two main layers, the inner core and the outer core. The inner core is a solid ball of metal that is under immense pressure due to the weight of the rest of the Earth pressing down on it. The outer core, on the other hand, is a liquid layer that is constantly moving due to convection currents. These currents generate the Earth's magnetic field, as the movement of the liquid metal creates electrical currents that, in turn, generate a magnetic field. The mantle. The mantle is the thickest layer of the Earth and is responsible for driving many of the geological processes that we observe. The mantle is made up of hot, semi-solid rock that is constantly moving due to convection currents. These currents are driven by the heat generated by the core and the radioactive decay of elements within the Earth. As the mantle moves, it drives the movement of the tectonic plates on the Earth's surface. This movement is responsible for the formation of mountains, ocean basins, and other geological features. The mantle is also the source of magma, which is molten rock that can rise to the Earth's surface and result in volcanic eruptions. Plate tectonics. The movement of the tectonic plates on the Earth's surface is known as plate tectonics. Plate tectonics is driven by the convection currents in the mantle and is responsible for creating many of the geological features that we observe on the Earth's surface. The movement of the plates can result in the formation of mountains, such as the Himalayas, or the creation of ocean basins, such as the Atlantic Ocean. The movement of the plates can also result in earthquakes, as the plates grind against one another and release energy that has been stored up over time. Volcanism. Volcanism is the process by which molten rock, ash, and gas are ejected from the Earth's interior. Volcanic eruptions can occur on land or under the ocean, and they can result in the formation of new land, such as islands or volcanic mountains. Volcanic eruptions can be devastating, as they can cause damage to infrastructure and result in the loss of life. However, volcanic eruptions also play a critical role in shaping the Earth's surface, and they can create fertile soil that is ideal for agriculture. Convection currents in the mantle. One of the critical drivers of geological processes on Earth is the convection currents in the mantle. These currents are driven by the heat generated by the core and the radioactive decay of elements within the Earth. As the mantle heats up, it expands and rises towards the Earth's surface. Once it reaches the surface, it cools and sinks back down towards the core. This movement of the mantle is known as a convection current, and it is responsible for driving the movement of the tectonic plates. The movement of the tectonic plates is caused by the interaction of these convection currents in the mantle. As the mantle moves, it causes the tectonic plates to move as well. The tectonic plates can move towards each other, away from each other, or slide past one another. These interactions can result in geological processes such as the formation of mountains, ocean basins, and earthquakes. Earthquakes are a result of the movement of tectonic plates on the Earth's surface. As the tectonic plates move against each other, they can get stuck, causing a buildup of energy. When the energy is released, it can result in an earthquake. Earthquakes can be incredibly destructive, and they can cause significant damage to infrastructure, result in landslides and tsunamis, and even result in loss of life. Volcanic eruptions. Volcanic eruptions occur when magma rises from the Earth's mantle to the surface. This magma can be released through volcanic vents, resulting in an eruption. Volcanic eruptions can be explosive or gentle, and they can result in the formation of new land or the destruction of existing land. Volcanic eruptions can also release harmful gases and ash into the atmosphere, which can have a significant impact on the environment and human health. Magnetic field. The Earth's magnetic field is generated by the movement of the liquid outer core. As the liquid metal moves, it generates electrical currents, which, in turn, generate a magnetic field. This magnetic field is critical for life on Earth, as it protects us from harmful solar radiation and allows us to navigate using a compass. Conclusion. In this video, we have explored some of the key processes that are happening inside the Earth. From the molten core to the outermost crust, the Earth is a dynamic and ever-changing system, driven by convection currents, plate tectonics, and geological processes such as earthquakes and volcanic eruptions. The study of these processes is critical for our understanding of the Earth's past, present, and future, and it can help us to better understand and mitigate the impacts of natural disasters. Plate tectonics. As we mentioned earlier, the movement of the tectonic plates is driven by convection currents in the mantle. Plate tectonics is the scientific theory that describes how the Earth's outermost layer is made up of a series of rigid plates that move and interact with each other. This theory explains many geological phenomena, such as the formation of mountain ranges, the opening and closing of ocean basins, and the creation of volcanic islands. Mantle plumes. Mantle plumes are columns of hot, buoyant material that rise from the boundary between the Earth's core and mantle. These plumes can cause volcanism and deformation of the Earth's crust, and they are thought to be responsible for the formation of some of the world's largest and most famous volcanic features, such as the Hawaiian Islands and Yellowstone National Park. Mineral and rock formation. The Earth's interior is composed of a variety of minerals and rocks that are formed through a range of geological processes. Minerals are naturally occurring substances that are formed through chemical reactions and crystallization. Rocks are made up of one or more minerals and can be formed through a range of processes, such as cooling and solidification of magma, or by the compaction and cementation of sediment. Geothermal energy. Geothermal energy is heat that is generated from the Earth's interior. This heat is used to generate electricity in geothermal power plants, which tap into naturally occurring geothermal reservoirs. These reservoirs are formed by the circulation of water through hot rock formations in the Earth's crust. Geothermal energy is a renewable and sustainable source of energy that is being used in many parts of the world. Geological timescale. The Earth is estimated to be around 4.6 billion years old, and the study of its history and evolution is a fundamental aspect of geology. The geological timescale is a timeline that divides the Earth's history into different periods, epochs, and ages, based on major geological and biological events. This timeline provides a framework for understanding the history of the Earth, from the formation of the planet to the present day. Conclusion. The Earth is a complex and dynamic system, and there are many processes and phenomena that are happening inside it. From plate tectonics and mantle plumes to mineral and rock formation and geothermal energy, the Earth is a fascinating subject of study. Understanding these processes is essential for our understanding of the planet and its history, as well as for developing sustainable approaches to managing our resources and mitigating the impacts of natural disasters.